Good day everyone. It's a pleasure to be with you here. First time after 3 years from COVID time, so pleasure to be with you. Today we'll talk about serving toward the edge. Hopefully you find it beneficial. Yeah? So we will talk about the importance of edge and basically what is the role of broadcaster in this environment. But first, let me tell you about the new reality. We have an explosion number of devices. Now, it is expected that the number of devices will be jumped from 12 billion to 24 billion by 2030. And usually these devices will need connectivity from cloud to edge up to the extreme edge, as you can see here on the slide. Basically, these devices now are kind of AI-driven, artificial intelligence. They really need a lot of traffic. And basically the importance of edge become really crucial in this environment. The edge has to basically traffic offload from the core network, from the cloud, otherwise the cloud cannot sustain the amount of traffic. But most important for AI is basically low latency. That's why edge is very important. Of course, as well, we see an enhancement technology in terms of connectivity, and that's why here you see on the screen a multi-connection toward the extreme edge. Usually these devices will be, for example, at house, and one device will provide the connectivity to multiple devices. As well, we see an important evolution in terms of protocols. Multi-pass TCP is one of the protocols that has been developed in order to provide connectivity, or basically can provide traffic across multi-connectivity. So really, multi-pass TCP and multi-pass UDP will play an important role when you have a multiple connection toward your extreme edge. Now, this use case is go mainly onto enterprise and as well broadcasting. This can go from healthcare to manufacturing to farm to ports. Really, they have a lot of devices at the edge, and they need to feed all of these devices from the network. And you can imagine when it comes to security, that you have a security problem for these connected devices. So basically, the edge become more and more important, and as well, extreme edge is as well important. For broadcaster as well, there is an opportunity for broadcaster, and we will see how this is covered in the few slides that I am presenting here. Now, broadcaster is definitely, there is an opportunity for broadcaster, which is ATSC is one of the connectivity. But the ATSC3, which is the terrestrial broadcasting, has very good advantage. They are one to many. They basically stream one copy. So let's say you have a file of 1 megabit. This 1 megabit can reach to a lot of devices only from a single spectrum. So it's an efficient way of basic delivering content to devices. Moreover, ATSC3 will come with a full stack IP. Comparing to ATSC1, ATSC3 is now removing the boundary between internet and broadcaster. So today on ATSC3, the protocol is full IP. The device getting an IP multicast from the network, and they can provide basically a local content into other devices. So basically, we are going out from the traditional TV, and because ATSC3 support one-to-many, now we are going into mobility, into IoT, into connected car. Really, there is a big enhancement in terms of what services we can tackle by ATSC3. So obviously, this can be achieved by having an edge. Every station become an edge. And this edge, the systems that power this edge become basically installed on a cloud edge, and it will provide these services into the network. We will see later on how this concept become really a network and provide you services at a scale. So the main objective, basically, what has to be done for broadcaster is really a full transformation. Nowadays, a broadcaster has station. These spectrum are really valuable. However, they are kind of discrete system. Every station is having a configuration for TV channel, but these TV channels basically will go on only into a specific area. The idea is to transform this kind of network, which are completely isolated, one station to another, to the one that we are showing to you on the left side of the presentation, where you have a broadcast core, and every station, every antenna, basically it's an edge. It's an edge system, and all the edges are basically connected to a single core network. This is a way you need to do it in order to offer services dynamically, right? So imagine you need to offer a data casting service, so a non-real-time service, and you need to allocate services across your different network. So you have to do it through a single point, and this will be the broadcast core system. So it's a control layer that manages many stations in your network, and in this case you will be able to dynamically allocate services into your spectrum. So you can transform your network to a wireless network that can be competing with the telco network. Now in HPE we have partnered with ARC, and we have developed this concept, exactly the one that I am showing you here. So from a broadcast core, you control all your station. So we have worked together. Here I'm putting just a snapshot of the portal. You can see here on the left, basically the topology, where you have multiple stations connected together into a central location, and we can see what services has been activated. This is the top slide here. So we see we have a number of stations, 2 stations connected to a core, and one of them has already some services going on from the station. As well, we have a kind of service catalog. This is where you can select what services you want to activate. You can see we have multiple type of service, but mainly it has the data casting, which is most important in this new use case, right? This is why you need an orchestration layer in your backend system. This is why you have to have this dynamic service allocation. You can achieve it by having a broadcast core network. This is just a view about what services are going on, and you can control these services, all of them, from a central location. So this is just a snapshot of the system that we have developed in order to realize this vision. So basically, what is a broadcast core? It's a virtualized multi-tenant system. It's basically an edge-to-cloud architecture enabling dynamic application and service deployment in different markets. So this is a system that provides the edge to cloud, the same concept we talk about. Moreover, it is an end-to-end solution. It's an open architect. We are agnostic, so we integrate with multiple broadcast components, and we can achieve the orchestration from the system, from the broadcast core network. Moreover, we provide a portal. So the BVNO portal, this one is a multi-tenant. Definitely, a host company who has multi-edge across their network, they can monetize their spectrum. So a vendor or basically a customer who wants to rent services or rent spectrum, he will be able to control his services from the same portal. So it's actually a multi-tenant portal. What we call it broadcast virtual network operator. It's a spectrum slicing concept where the customer can enable his services from this portal. Moreover, this is as well a snapshot about the data casting service. This is a type of service that it's important in ATAC3. We have as well a solution. In the same portal, the customer can basically select the service. It can upload the content, and it can basically, you can see on the you can see here on the last slide. It can basically broadcast these files into multiple stations. So it's a full solution for data casting as well. I don't believe any competitor has this type of service. So we bring all your station and you control it from a single location. This is really, important value proposition. I know that Josh was talking about this in previous meeting. So and we are very proud to work with Josh to meet this vision. So eventually, this is a reality at the end. So ATSC3 will be part of the ecosystem. You can see here, you have the CPE, which is a consumer premise equipment. It got multi connection, right? It got the 5G LTE, it can get the wireline connectivity, but ATSC3 is another way to deliver service and deliver content to the end user. The benefit of it, it's one-to-many, and you can see this now with IoT. You have on the field thousands of devices that all of them will get exactly the same type of content. Imagine, for example, a connected car on the road. Let's say 200,000 cars that need to get as urgent as possible a software update. In Unicast, this will not work. In Unicast, this might take months to get to every car. However, in ATSC3, because of the one-to-many type of service, of technology, this can reach all of them within a few hours. So it's really important. It's just a matter of now getting this ecosystem, and we are working with ARC into realizing some of the use cases that will prove the importance of ATSC3. So obviously, the end game will be every component will have multiple connection. The device itself will select the best way to get traffic. If it's meant for being broadcasted, so many devices will get it, then the traffic will go over ATSC3, and this will provide a high quality of service for the end customer. Then, basically, with this solution, of course, we are solving some challenges. One of the challenges is limited coverage. Usually, ATSC1, which using a different standard for encoding, with ATSC3, you definitely have an enhanced coverage. As well, because ATSC3 use OFDM, which is very much comparable with 5G, mobility become a possibility. So basically, traffic can go. Operator can offer multicast service over ATSC3. It will be reaching by mobile. Moreover, you might have a gap in terms of services. So in some places where you have an event, OTT service cannot cope with the demand of Unicast. So of course, a broadcast internet, FCC has allowed this, and ATSC can basically offload the traffic in such scenario to ATSC3. So you save your bandwidth. So I would see it as a complementary for ISP, and they can work together in order to enhance the service and offer an enhanced and accelerated quality of service for customers. Moreover, because ATSC3, our solution, offer a BVNO portal. Basically, any customer, any enterprise customer can rent services from the host, and they can do this through a capacity as a service. So whenever there is a need for offloading traffic, a BVNO can come and rent services from broadcaster. So this is as well another advantage that the solution offer for broadcaster. Okay, now we jump into as well another area of benefit, which is where a broadcaster can benefit from enhanced connectivity. And one of them is basically media production through the cloud. This is definitely, when broadcasters are deploying all the edges, this goes into a cloud type of environment. It's a virtual environment where different type of services can be activated. And one of them is the production as what we call it as a service, or broadcast as a service. Here, the broadcaster can basically produce content as near as their edge. So the system will offer a different media function like playout, like graphics, and media distribution. So like editing machine on their near edge. Of course, the benefit of near edge is latency. As you know, production is very important to have as close to the customer as possible, or as close to the production site. So usually an edge location can be used in order to reduce latency, enhance the service, and eventually produce content as a scale. So this is another solution that pretty much follows the same architecture, so edge importance is there. So we are showing these solutions in our HPE booth. We have, sorry, we did not put the booth number. It's 9811. It's pretty close to here. It's 8911. It's pretty close to here. I think maybe 100 yards from here. We are showing the broadcast as a service. This is where we generate content from the cloud, which is an edge cloud in reality. We are doing as well the distribution, which is the next generation TV ATSC3, which is the system we are showing with ARC multicasting. And as well, we are enabling the automation, and we can show how with automation system we can realize and definitely capitalize on the infrastructure, on the investment that the customer do, and realize as much automation of process as possible. So please, you are welcome to join us there in HPE booth. Here we have some basically reference, some document. I will keep it in the slide. Thank you very much for your interest. I hope this provided a good overview of what we are showing in this show. Please feel free to approach me for any clarification and questions. Thank you very much.